again, we talked yesterday about the swimmer going across across from one side to the other, right? So let's look at page 108, and if you can't cover up your solution there. A swimmer on the south shore of a river wishes to swim to a dock due north of a starting point. Its maximum swimming speed is, in still water, it's 4 kilometers an hour, and there's a current in the river flowing at 2.5 kilometers an hour towards the west. In what direction must he set out to continue swimming through the water? Okay, so just set the book aside now. Let's talk about it. All right, so first thing that we know, we draw our river. So it's a north-south river again. Okay. So this is where he is right here. The direction of the current is that way, right? And so yesterday when I did the whole question and I showed you how to end up on the shore, straight across, same idea. This is exactly what it is here. The first question I showed you that we actually, or the textbook that we did, didn't have this aspect to it, so I'm giving it to you again right now so we make sense of it. Okay, so I want to end up right here. So from here to there. So what direction does this person have to swim in order to get across and end up straight across from where they were? Okay, so they have to go somewhat to the east of the target area. You'd all agree with that?
Yeah.
Right, so I'd have to go somewhere up to here, correct?
Mm-hmm.
And then let the current blow us back, or move us back, not blow us, but move us back that way. Okay, so if that's the case then, is the person going to be swimming faster or slower? Slower, because you're swimming into the current, which is going to slow you down. So the velocity that the person swims is 4 kilometers an hour in still water, right? But that's still 4 kilometers an hour. That's what they're going to swim into the current. And the current is moving at 2.5 kilometers an hour. So if I was standing here watching again, me as the point of reference, right? It's going to appear that this person's going to go this way, this way, this way, this way, this way, all the way until they end up directly across. So let's calculate then, what is the velocity that this swimmer is actually moving if they are swimming into the current?
Pages on it.
3.122.
3.1.
4 squared minus 2.5 squared and squared.
All right. This is a right triangle, Brock. So I have Pythagoras' theorem, right?
Yeah.
But I know what the hypotenuse is. So this squared subtract that squared gives me that squared. Okay? All right. I didn't look before I turned the book away. How far is the river across?
2 kilometers.
What was it,
2
Kasha?
kilometers.
2 kilometers wide. Thanks. Okay? So then, what's the time it's going to take for that person to swim across? How do I find it?
Distance over speed.
Distance over speed, that's right. So 2 divided by 3.122.
0.641.
Okay, take that value, don't erase it, and times it by 60, please.
38.437.
38.437. 437, and times that value by 60.
2,306.214.
All that. So, it's going to take 0.641 hours to get across, right? Which is equivalent to the same as 38.437 minutes, or 2,306.214 seconds to get across the river. Okay?
My answer is a little bit different. That doesn't matter. It's just
Did you erase your...
I didn't.
You didn't? So what did you have different then?
Well, after I timed the 6 4 like 1, I timed that like the whole thing by 60, which is 38.431. Times that by 60.
I have 4,369.
Did you erase yours at all or
No.
no? 2,305.
So right here, did you go 2 divided by 3.122, both of you?
Or I think I just went 2 divided by my answer, so you would have more than
Right, so you could be more accurate than that, right?
Oh,
Okay, so we did this yesterday, right?
Mhm.
Do you remember this from yesterday? Yeah? Okay, so then it says, what angle does this person have to swim at relative to the shore? So the first thing I want to do is find that angle first. Is that the one relative to the shore?
Yes.
No. Oh,
no, the one on the far side.
right.
Well, no, I fell for that.
It sounds like
I said, yep,
you're very disappointed that you lost it.
that one is relative to the shore.
Right, so.
Swimming this way relative to this, right here. Okay, so the first thing you have to do is find alpha in the brackets. Second function sine 2.5 divided by 4. And then subtract that from 90 to get your answer right here. Okay, which is the angle that they're looking for. Okay? Now, I see what they did here, and I would suggest this to you. I may not put relative to the shore, but if it does specify in the actual instructions of the question, it gives you north, south, east, west as parts of the question, then your answer should be north, south, east, west as parts of your question. Okay? So I would actually, instead of saying relative to the shore, I would say, well, he's got to go east and then this much to the north. Okay? Or going north and then that much to the east. Does that make sense to everybody?
Does that matter, like what you put first, like whether you put the north?
Yes, it does, absolutely. Yeah.
Whichever one happens
Because-
first.
All right, somebody calculate this for me, please. 2.5 divided by 4, second function sine. Go ahead, Paige.
38.682 degrees.
682,
682 degrees, which makes this one what?
51, and 307.
18?
Yeah.
Degrees. Okay, so to answer your question, Amy, you're always given the first direction that you're going and then where you go from there. So if I said north, was the first direction, that's this way right here.
Yeah.
So then I would say north, 38.62 degrees to the east.
Okay.
Okay?
I have a question.
If I say east, 51.38 to the north. Both are correct. Go ahead.
How come on certain questions it'll say stuff like that, but the answer will be like southwest? It'll be like, you start here, you go north, and then you go east, and it'll be the total opposite direction and stuff.
Well, the only word, and you see this is part of this is the one trick with the vectors that you have to get used to, is when you're drawing them, you have to know how to draw them and find the correct angle.
Properly, so it matches. the
Right?
description.
Exactly. So it matches what you're actually trying to explain. And you have to think about it like this, Rowan. I'm going to explain to somebody, this guy standing right here, hey, look, if you actually want to end up at the speed you're going to swim at and you want to end up going across, then you got to swim exactly east, 51.38 degrees, 318 degrees to the north to get there. So you have to explain it. Now, I can draw triangles one of two ways. I can go north and then east, or I can go east and then north. But the key to the whole thing is finding the angle that you have started with. Okay? So this is the mistake that gets made if we don't draw them properly. We don't go to the spot where we are actually starting from. Okay, so I'm not sure if that answers your question because I don't have an exact example, but they will always put direction, angle, magnitude, direction. Okay? You can find it, I'll answer it. All right, so go ahead.
Back to Amy, then you always put the direction that you want first. in
Yes.
the thing.
100%. Okay? That helps you too?
Yeah.
Okay? All right. How did we do yesterday? I gave you about six questions yesterday. How did we do? Feel free to do homework with me yesterday.
I didn't do it. Excellent.
Oh,
Found the
I'm
question.
having lunchtime today. Yeah, did you?
Number 3 on 97.
Yep.
Says like a car traveling 50 meters north and then it was 18 meters per second east.
Okay, yeah. Okay, I wanna,
Southeast.
yeah,
East, south.
I'm gonna explain this. All right, so the one thing that I did tell you, when it comes to drawing vectors, we have to use equations. And the equations help us to draw the vector. They're like telling us, that's our information, how to draw the vector. So it says a car traveling at 15 meters per second north executes a gradual turn so that it is now moving at 18 meters per second to the east. What is the car's change in velocity? So change in velocity is found by taking what? How do I find the change in anything?
V2 minus V1.
Perfect. So I've got to go V2, and I have to subtract V1. Follow me so far?
What's the question,
Okay.
sorry, so I
97.
Page 97, question 3. Okay, you follow me so far? So now, according to the information that was given, which vector is V2 in this?
On the bottom of the question.
18 meters per second east.
I know what it is. So V2 is 18 meters per second to the east. So I'm going to draw that. There's V2.
Yeah.
18 meters per second to the east, right? What is vector V1 in the question?
15 meters per second north.
Yeah, it's to the north, right? But the problem is, I need the negative of it. So what's the negative of V1? So instead of north, it's south. So I draw it like this.
Yeah.
Does that make sense now? Yeah. Okay. And that is exactly the mistake I expect you to make if you're gonna make it.
I remember you explaining that, how you, instead of taking it away, you just add the negative.
Right. And just change the direction.
Why?
Okay? Does that make sense to you now? So that's why it didn't. The angles were different than what the question was, because I have to use this in order to do it, and I'm not actually adding two vectors together. I'm actually subtracting them, but I'm adding one and the negative of the other one.
Yeah.
Okay? So that's why this question here ends up being east so many degrees south.
Okay.
Okay? That right there is what I would expect a mistake to be made. Okay? And that's why I say you need to write your equation out so that you know how to draw your vectors after that. Fair enough? Okay? Anything else from the day's work yesterday that we came up with that we had or maybe need an extra explanation for?
You do 4 on 97?
Sure.
Like it's similar, but
Okay. So, again, I'm just going to write this here right now. Okay? So that change in velocity. All right, so read the question to me and just give me what the first part says.
the plane is flying at 100 meters per second east.
So the first thing that I know is that I've got V1 is 100 meters per second to the east. Right?
Yeah.
You get that from the question? Okay. What's the second part of the question say?
30 meters per second.
East 30 degrees north.
Okay, so then it's giving me that right there, correct?
Yes.
Its change in velocity is 30 meters per second, and then it gives me a vector, right?
And it gives you the angle.
What is it, east what, 30 degrees north?
30 degrees north.
So I've got east 30 degrees north. That's that guy right there. That's my change in velocity. Now, how fast is it going? 30 meters per second? So I have this right here.
I don't like this one.
Okay, so are you following me so far?
It's
So all I've done, and this is similar to what I asked you to do in the last section. Remember in the last section I said to you, list out all the things that you know. So you put V1, you put A, your V2, your D, and your T, right? So you list all of that there, right? Right now what I'm trying to do is I'm trying to list my vectors that are given to me. Okay? Now let's piece this equation, this whole thing together. I know what this is, and I know what that is, right?
Yeah.
So it's asking me to find its
V2.
V2. So to arrange this equation, what would I get? V2 is equal to
The average plus V1.
change in velocity plus V1. Yeah? Okay. You like law of sines and cosines?
I guess so, yeah.
Okay, so then let's draw this first. This guy first. Right here. In which that angle right there is 30 degrees. So far, follow me?
Mhm.
Now I gotta add that one to it. So do I draw it down here?
Maybe, I don't know.
Where do you draw your second vector to?
The tip of the,
At the tip of the next one. So you do know that, right?
yeah.
Okay, so that goes right there. So I've got 30 meters per second here. I have 100 meters per second right here.
Oh,
I'm looking for that guy right there. Okay. Here's what else I know. I know that this is 30 degrees right here. Got 30 and that 30 right there, right? Which means that I know the middle angle here, which is what? 150. Now you can find out what V2 is using the law of cosines. Okay? So this part's easy.
well, that's why I wasn't working. I was just trying to go 100 squared plus 30 squared and then square root that, but it wasn't a right triangle to begin with, so.
That's right. That's right. So law of cosines now minus 2 times 30 times 50, 2 times 100 times the cos of 150, right?
Yeah.
Okay? That part's easy. Here's the part when you're doing these questions without doing the right triangle. Getting your angle correct.
Oh, yeah.
Okay? So right now, from here to here, to the red, is 30 degrees, right?
Yeah.
You're going to find out what that green is, and then you're going to describe the path of the green, which is actually only from here to there. So that blue, how would I find out what blue is? Once I find my green.
Get the inside angle subtracted from 30.
That's right. So I'm going to go east so many degrees to the north, but I'm not going to go 30 because that's the change in velocity. So that when you use your law of sines there, that's where we have trouble, is getting the angle correct. Okay? Now, if I were to do this question, just a second, Austin. If I were to do this question using right triangle trig,
I know it'd be easier.
come on, I think this is easy, but you're right, it could be for some. I would find out what my two components are right here, right now. So this one is 15 meters per second, I know that, because the sine of 30 is a half. What is cos 30 times 30? Somebody punch that into the calculator, please.
Cos 30 times 30.
25.981. Maybe meters per second, or no?
Yeah, that's right. So there, I have one component, two components, three components. And I can just do an XY chart now. So I'm actually going to add the two east together, and I'll have 15 meters per second to the north. So my right triangle actually for this question, to do it quite quickly, my right triangle for this question would be 125.981 east, 15 to the north, so you know what? Probably easier to do it with the right triangle, wouldn't it be? Okay? And what I would calculate is I would get that value exactly the same as this value. Okay, you want to ask you a question now?
With your V1 on the other first page, if you put your V1 first and then your change in velocity, is that the
Okay.
same, or you always put your change first?
No. It won't matter, Austin, to answer your question, okay? Because you're gonna end up with this. That. All right, in which this is 30 degrees right here. Okay? But that and that's gonna be the same thing. It's gonna give you this. So you have to find this, which will give you that. So that might be easier that way, okay? So, would it matter? No. My point to this right now, Austin, is I want to do what that tells me to do. So if it says change in velocity first, put it first. Not because of this question, because of the next question I'm going to show you with a plane. Okay? So, Rowan, find these two components. Because I had two east that added up together, right? And then I had the north component. Now I'm just using right angle trig at that point, and Pythagoras' theorem.
127, or 126 decimal, whatever, if I round that to around still 127.
Or 126 still.
Yeah, but answers 127.
Then you give me what you got,
Oh,
because we're going to be different than the book. The book rounds too fast all the time.
126.871. Right?
Perfect. Meters per second, and then you would just find second function 10, 15 divided by 125.981.
hold up, he's looking over real quick.
Yeah, so repeat.
Second tan 15.
Divided by this, yeah.
And then second something like that one. Because you just get decimal 6.
Goes second 10,
Oh, tan, that's why.
In 125.6?
15 divided by this number right here.
Yeah, you just get decimal 6.8. Would you second tan that one then?
Yeah.
34.
Yeah, yes. Second 10.
Yeah, that's what I was.
Did you get it?
Yeah, 34 decimal 377.
30.
I don't.
I got 6
That's
plus 7 nails.
Costa,
Yeah.
help me out
He's
here.
right. He's right.
Yeah, I got the same as what
It's an
I got.
answer 7. It's, I'm wrong. I don't know how.
Six.
Okay, I want you, I want you to look at this question for a second. What was the original degrees that I went?
30.
30. So is it possible that I went further than that?
No.
According to what I drew here. I'd end up over here, right? Which is no good to us.
Yeah.
Right?
Yeah.
So it has to be
Oh.
smaller than that. So I know that I made an error there. So now I go back and I look at it. All right. So
6.
How do you get 6?
Tan to -1 because you're finding an angle 0.
yeah, I think you have using
Do you put the 1 in front of the 25 wrong? Because I did it and then I got it.
Oh wait, I know what
Why
I
do
mean.
you
have that in a bracket?
Oh, that makes
What is it? 6 point what?
Tan 15 divided by
Bro, you put
Yeah, so you know what you're...
This one's second tan 15, and then that divided by 1.
Exactly. Exactly, right? Yeah. Okay. So that means then,
Yes.
if I were to go back to the original here that I was working with,
So we try
what do you think this angle was if I used my sine?
7 or 6 point whatever.
20.
No, the angle from here to here is 6 point something. So,
24.2.
right, it would be, you would take 30, subtract that,
Okay.
right? Okay? How's this? Anybody confused on this?
Not confused, it's just a lot.
Yeah,
well, I
but
keep thinking
it's
they
gonna
have
get
to do
worse.
both of them for some reason.
Pardon me?
They had to do both of them for a second. And then
No.
Scooby-Doo.
No.
You just start one and you start the other.
You can do whichever one you like best. So again, I'm encouraging you to use whatever method you like best. If you like law of cosines and law of sines, go ahead. If you're more comfortable with right angle trig, which most of you should be, then just find individual components. So I start by listing out my vectors and then find my individual components of them. And then just draw right triangles. And then you just only have sine, cosine, tan at that point. Okay? Any other questions from the work I gave you? All right, I'm going to show you, because I'm away here tomorrow, I'm going to show you the questions on page 109. Question 1 and 2, we just basically covered both of those. Okay, so question 1 and 2. Question 3 is the one I want to talk about.
Mine's circle.
Does everybody see that? Page 109, question 3. Are we all there?
Yeah.
Okay. Pilot wishes to make a flight of 300 kilometers northeast in 45 minutes. On checking with the meteorological office, she finds that there will be a wind of 80 kilometers an hour from the north for the entire flight. What heading and airspeed must she use for the flight? Okay, so I want to talk about the question before we do any math part of this, before we do any of the actual components, before we do anything with the equations. I want to just talk about it. All right, northeast, basically speaking, you know, is from here to here. And what do we know about the angle?
45.
So this is 45 degrees right here, right? So the person wants to go northeast from there to there, right? But it says that the wind is blowing
North.
from the north,
So it's going south.
so it's blowing south, right? So where do you think I should point this, or where should she point this airplane so that she ends up exactly where we want? Rex?
Couple degrees more to the north. Yeah.
Yeah.
West.
Push down.
No.
Yeah, west.
More west.
More
Yeah.
west?
No, more towards the north, guys.
Well, no, more towards the west.
The north.
From the
Yes,
line.
you
Yeah,
can.
you can. They're going northeast.
You can't point more towards.
Kasha, go ahead.
You can't south.
More to the north. Brock and Kasha say more to the north.
Well,
No.
same.
Okay.
I don't know.
More left, like straight in your
So-
arrow.
So the wind is blowing in that direction.
And you're trying to get to there?
And I need to get to here. So somebody draw it. Brock, go ahead and draw what you're thinking.
I don't know.
I know what I'm thinking.
You don't know.
Yeah,
Yeah,
let's go ahead.
into it. I'm pretty sure we're all thinking the same thing.
We
We're just
are.
arguing
We're all
over
doing
it.
the same thing, we just don't want to see it.
If you would go like,
That's awesome.
I gotta draw it.
okay, the wind is blowing from above, that means like that your angle will go more like that because the wind blows you down.
Yeah.
That means you have to go more like this, that you end up there.
But from that starting point, you have to go
From the
straight
starting
up.
point. I'm
Yeah.
starting right here. So which way am I gonna go?
Like this.
Yes.
That the wind is blowing down to that.
So like north, east a bit.
Okay.
No.
All right. So not bad. You got exactly what I'm looking for here in terms of the angle. So the angle of what Kostya has drawn is right. Okay, the angle, this has to go more to the north than what the 45 degrees is, right? I have to go slightly above the 45 degrees to get there. Do we not agree with that? So you're kind of saying the same thing, right? Okay, now, I'm going to put it to you like this now. I want to go northeast. So, in order to go northeast, I have to take the wind into account. So the plane's going to have a speed on it, right? The plane's going to set its speed, its cruising speed, and then the wind's going to affect it. So when you put the two together, we call that the ground speed. That means if I'm looking up in the air and I'm watching the airplane fly above my head, the airplane speed and the wind speed are taken into account from what I'm seeing. So if it was going 400 miles an hour, kilometers an hour, whatever, the wind would be affecting it. So to me, it might only appear to be going 385. Might appear to be going 420. Because I'm standing on the ground watching it, and it's taking the speed of the airplane and the wind into account. We call that ground speed. And to calculate my ground speed, all right, I add my plane speed and my wind speed together. So yesterday I talked about swimming and the current, right? Same thing, except it's in the air. The person swimming and the current added together would give you what somebody standing on shore would see, right?
Haley Allen to the office, please. Haley Allen.
Okay, so does that make sense? All right. Now, in this question, it says that the plane wants to fly 300 kilometers in 45 minutes to the northeast. That's taking into account the plane speed and the wind speed. So therefore, I could actually find out what the ground speed should be in order to make it in 45 minutes. Because I have 300 kilometers, I have 45 minutes, which is 3/4 of an hour. Can I find out how fast that needs to be? Okay, so let's do that. Let's find out what this vector is right here. So I know it's 45 degrees, right? So I want to take 300 and divide it by 0.75.
400.
So between the wind and the speed of the plane, in order to get there in 45 minutes, he has to fly 400 kilometers an hour. Okay, so far? Yes?
What's their ground speed?
Sorry?
That's their ground speed?
That's our ground speed. Now the wind is blowing in this direction right here, 80 kilometers an hour, and he's blowing into the south, correct? So far so good, right? Any questions? Okay? All right. So right now I have this guy, and I have this guy. What am I looking for?
Plane speed.
The speed of the plane. How fast is the plane going to have to fly in order to fly into the wind and end up getting there in 3/4 of an hour? That's what I got to find. So let's arrange that equation so that I isolate VP. So VP is equal to
Ground speed, subtract wind speed.
ground speed, subtract the wind speed. Okay? So far so good?
Yeah.
All right, great. So now what I'm going to do, I'm going to draw this. So the first thing I'm going to draw is my ground speed. So I'm going to draw that right here. Oh, too far. Velocity of the ground, 400 kilometers an hour. That's VG. Now, I need to draw the negative VW. So instead of it being, I'm going to make it north, right? Okay, so I want to show you something. So I'm going to go up like this, just like that, right? 80 kilometers an hour. That's my velocity of my wind. Actually, the negative velocity of it. And it's now north, correct? So the velocity of the plane then is this resultance right here. Is that right there? That's the velocity of the plane. Okay, so far? Any questions? Look what Costa drew. He was kind of on the right track, wasn't he? He cut it off right here to show that the wind is blowing, but if he had kept going all the way up to here, he'd got it right. So he knew what to do. Fly to the north, further, and then end up where you were supposed to end up. So far, so good? Okay? So again, at this point, this is 45 degrees down here, agreed? Which would make this 45 right here, so this whole angle is 135. If I made a parallel line here, 45 and 45, and then add the 90, so 135 degrees right there. Now I can use the law of cosines and I can solve to find out what the velocity of my plane is.
Oh, you can do that. Oh, there's not already.
It's not right angle right yet, but I can do this question with the right angle. All right? If I was doing it as a right angle, I would find this component here and this component right here. Okay. Cosine 45 by 400, please.
Sine 45 by what?
Sine 45 times 400.
282.843.
And that is north. And 282.843 to the east. So far, so good. Right, those have to be the same. So I've got two 45-degree angles, correct?
Yeah. Okay.
So drawing my right triangle, my resultant triangle, I know that I'm going 282.843 to the east.
And same thing to the north. Oh, triangle says 202.8.
Okay.
Subtract the.
I have a north and I have a south component, so I would subtract those. So I'm going to get
202.
202.843 to the north. Now, Amron, I have a right triangle. Now you can find the velocity of the plane. The more I do the right triangle stuff, the easier it looks than the rest, doesn't it? Just by finding your components and then adding them together. Okay, how'd you make out?
348.06.
060?
Oh, yeah.
And that would be kilometers per hour. Okay? All right, and I need that angle to tell us so second function 10, 202.843 divided by 282.843. Using your brackets again.
Yeah. 35. 606.
35 point.
I'm wrong.
I have no idea. I mean,
0.646.
646 degrees to the north. Is that what we got there? Yeah? We agree?
Yeah.
We agree.
that's not the answer. He says
All right, I have an issue with this.
you have to add it to their.
No, I just want you, just wait. Let's ignore the math problem for a second. Let's ignore the math problem for a second, okay? Let's talk about the physics problem that we just brought up,
Oh, yeah. Yeah.
all right?
Has to be.
I have to fly further north than the 45 degrees, don't I?
Yep.
So then, somehow, some way, I've got far too big, or far too small of an angle if this is only 35.646 north. Because that's only right to here. Okay, so let's check our math again and see what we've got right or wrong. So let's try second function 10 again.
Mr. Newton,
I got an issue with this.
how did you get the 282.843? I tried doing my calculator, not getting anywhere near that.
This guy,
Yeah,
for here,
yeah.
Sine 45.
sine 45 times 400
400.
Okay, now I'm gonna throw a few things at you. I wanna throw a few things at you, because I'm trying to make more sense out of what we're doing. Is this angle bigger than this angle? Which angle would be bigger, here or here? Top or the bottom?
Top. I didn't say angle.
No, yeah, it's not. Top would be bigger.
Why?
Because 282 is bigger than 202.
Right. So then what's the problem here? How are we getting this wrong?
Do you know? Or you just like, trying to make us figure it out.
This is a wild guess. Like, what if you add 45 degrees to it?
That ain't get cheap.
I don't know.
No, that's not a terrible plan. Problem is that there's gotta be something here that we're missing, right?
When you did the ground speed, I didn't understand why you did velocity divided by time.
Okay. What's that?
Shouldn't you do velocity times 45 minutes? Because you did divided by 0.75. Shouldn't it be times that?
No, it's distance divided by time. 300 is a distance divided by time. Okay, I'm gonna show you where your error is. The error was, thankfully not a physics error, it was a math error. Okay? And that error comes right here.
That's wrong.
I want you to look at your two components right now. This was 80 to the south, right?
No, switch it around.
But I needed the negative 80 to the
Awesome.
negative north.
So add 160 to
So I should have added 80 to 282 instead of subtracting it.
So when we always put our, like, the X, like, you know how you get
Oh,
X
160
table
though,
and
bro.
a Y table?
No.
160 to 202.
No.
No,
Austin.
because he subtracted
No,
just doubled
Austin.
it. Yeah.
Oh, yeah, he's right. He's
He's right.
supposed to. No, but from
Oh, add it to-
160 to 202.
So you add
Yeah.
80 to this.
Yeah.
Okay, so that was the error that we made. Because I drew it like this here, I gave you the actual positive one, but what do we need? We need the negative one there, don't we? So I should have redrawn it and gone like this and to the north. So now, that guy right here is gonna change everything.
It's going to be 300.
Okay, now I wanted you to, I shouldn't have erased that, darn it. Okay, I want you to think about something. This was 360 or something like that, right? It was 360? Should be bigger than
348.
348.3.
But it said I needed to go a minimum of what to get there in 45 minutes? 400. So there's no way that could have been right.
We screwed up.
Because the
Okay,
sun,
so
plus 4.
only error though. No, you guys are doing great things here. There was only one error though. That was it. If we do everything again, our math is going to check out. Okay, so let's put this back in as 362.843. And let's get that there. Okay? So the only physics error we made here is we did the subtraction of this vector instead of the addition of the negative. Right? Yes, because we didn't look at
Excuse
the
me, Nick,
formula.
go to the office, please. Nick, go to the office.
Okay, so what do we get here now? 282.843 squared plus 360.
460.
460. Decimal what, sorry?
060.
060 kilometers per hour. So is that greater than the 400 that if we had no wind?
Yeah.
Yeah. Okay. And now let's get this angle.
52.063.
Oh, that's the answer. Good at that.
Right on. Right on. Okay. So one small error. All our math looked great. But some of our logic didn't fit, did it?
Yeah.
First of all, we had a speed that was less than what we could have flown if there was no wind. Right? So that's a problem. Which would have meant that we would have actually gone faster if there was no wind. Okay? But we're flying into the wind, so it should have been a bit slower. But in order for the plane to get there at that same time, The plane has to fly faster because it's gonna go into the wind, right? Go ahead, Amber.
Like you draw it out first before you put it into your X and Y graph.
I do this first so that I can visually see that it has to go up here. That way I wouldn't have made a mistake. Had I seen this, instead of just drawing those two, okay, or I draw this and then I draw the negative of it immediately, okay? But, so now, just for the heck of it, use your coastlaw on this guy.
Yeah, it's the same.
So, square root 400 squared plus 80 squared minus 2 times 400 times 80 times the cosine 135. And you should end up with 460.060 degrees, or sorry, kilometers per hour.
What did you say to do?
So 400.
Using my cosine law, so you go square root, you open a bracket,
Yeah.
400 squared
Yeah.
plus 80 squared minus 2 times 400 times 80 times the cos 135 and close your bracket.
Oh, 460 is 6, so that is a good match.
Good. And then you would find that, what would this angle be approximately?
I'd be both. You don't know?
Yeah, you do.
I don't.
52.
No. What would that angle be?
Oh, never mind. Be,
Lost you?
7.06.
7 point something, right? Because this is 45 and the whole
Yeah.
angle to there was 52.
Yeah.
Okay? How are you making out? You doing okay? Not bad? Alright, the only thing I'm going to assign you is the other 4 that are on that page. So basically for Monday, you finish yesterday's work and the 4 from today. That means you got tomorrow to do it as well. Okay? Is there any other questions about those drawings? Okay.
I just wondered, so like, you know how you put it, they aren't like always right into the right triangle, like you sometimes gotta draw it into like a
Yeah.
non,
Yeah.
but it's like always able to go into a
It
right
happens
triangle
to
after you
anything
find
when you
your,
push down.
like
Yeah.
information.
Yeah.